Hello everyone, here's chapter 17, homework 4 that we're going to go over. It's mainly about the Le Chatelier's principle. Okay, let's look at the first question. The reaction system given to us is at an equilibrium. Which of the following describe the behavior of the system if POCl is added to the container? Now, POCl is a product, right? So you add that, so what's going to happen? The partial pressure of POCl3 and POCl will remain steady. It cannot be like that because one is a reactant, one is a product. So something has to change in both. So cannot remain steady. And then the reverse reaction will proceed to establish equilibrium. What do you think about that? Now if you add POCl, so POCl is a product. So when you add a product, which direction reaction would proceed? It's gonna go reverse direction, so it can use up the added POCl. So the reverse reaction will proceed to establish equilibrium. So that makes sense, B. And then the C, forward reaction will proceed. That's not correct. And then the partial pressure of chlorine remains steady, while the partial pressure of POCl3 and POCl increase. That's not correct either. The partial pressure of chlorine will increase. No, it doesn't increase, because now if the reaction goes reverse, so then the chlorine partial pressure needs to decrease. So the correct answer would be, it should proceed to left in order to establish the equilibrium. Okay. So the next one, the reaction system, same system. At equilibrium, which of the following statement describe the behavior of the system if the partial pressure of chlorine reduced by 50%? Chlorine partial pressure is reduced, meaning the pressure decreases. If you decrease pressure, what happened to the volume? Volume increases, so the number of moles also need to increase. So always have this relationship handy, so it will be easy for us to see what can happen. So you reduce the partial pressure of chlorine by 50%. Now if that happens, which direction would this reaction proceed? So like I said, if the pressure decreases, volume increases and number of moles need to increase. Let's look at the number of moles in the both sides. So here you have one number of mole, it's a gas, and here you have 1, and here you have 1 plus 1, 2, right? So the volume, the number of moles of the products is 2, number of moles of the reactants is 1. So the number of moles should increase. Describe the behavior of the system if the partial pressure of chlorine is reduced by 50%. So we are reducing chlorine. Okay. So if that happens, which direction should it proceed? So pressure is going down, so the volume need to increase and also the number of moles need to increase. Right? So which direction do you think that we can get the number of moles increase? 1 going to 2. So the reaction will proceed to forward direction. Okay. So if the forward direction is taking place, which one would be the correct answer? POCl3 will be consumed as equilibrium is established. Is that correct? Yes, right? So the forward reaction makes POCl3 to consume. B, the volume will have to decrease before equilibrium can be established. No, volume has to increase because the pressure is decreasing. POCl will consumed as equilibrium is established. POCl is a product, so it will not be consumed, it will make more. The partial pressure of POCl will decrease, while the partial pressure of Cl2 increase. Chlorine partial pressure increase is correct, but would the partial pressure of POCl decrease? No. Since POCl is a product, that will also increase. and then chlorine will consumed as equilibrium established. That's not correct either. Okay, so I gave you the answer for that, so you can find the correct answer from the choices. Okay, so the next one we have number 3, the reaction system. Carbon disulfide plus 4 hydrogen giving you methane and hydrogen sulfide. They all are gases, is at equilibrium. Which of the following statements describe the behavior of the system if the partial pressure of hydrogen is doubled? So hydrogen is here. Hydrogen partial pressure, we are doubling it up. Okay. So again, remember the pressure double mean you increase the pressure. What happened to the volume? Volume should decrease. The number of moles also should decrease. Now, which direction would this reaction proceed? So your reactants, you have 1 plus 4, 5 moles you have for the reactants, and 1 plus 2, you have 3 for the product. So if the number of moles need to go down, which direction do you think we should proceed the equilibrium? 5 to 3 or 3 to 5? It should be 5 to 3, right? So then the forward reaction will take place. So as equilibrium is re-established, the partial pressure of hydrogen decreases. Is that correct? So if the reaction goes forward direction, what happened to the partial pressure of hydrogen? Partial pressure rises due to the amount of hydrogen gas. So since hydrogen is consuming, partial pressure of hydrogen decreases, which makes sense and which is correct. Now let's look at the other options. As the equilibrium re-established, the partial pressure of hydrogen sulfide decreases. Hydrogen sulfide is this one. If the reaction is moving towards the forward direction, meaning we are going to make more of H2S, so then the partial pressure should increase. So that's the second. B is not correct. And then the partial pressure, equilibrium is re-established, all the partial pressures will decrease. That's not correct. As equilibrium re-established, the partial pressure of carbon disulfide increases. Carbon disulfide is a reactant. Since the reaction is moving forward, that CS2 is need to use up. So then CS2 partial pressure should decrease, not increase. And then the last one, partial pressure of methane decreases. Methane here again, it's a product. So if the reaction proceeds forward direction, you are making more of methane. So the partial pressure should increase. So that's not correct either. So the correct answer, we talk about it. So I hope you remember. Okay, the next one. The reaction system, we have CS2 plus 4 hydrogen giving you CH4 plus 2 hydrogen sulfide is at equilibrium. Which of the following statements describe the behavior of the system if the partial pressure of carbon disulfide is reduced? Carbon disulfide is this one. Partial pressure you decrease. Okay. So remember again, the pressure decrease means volume increases, number of moles should increase. So we have to look at which direction should the reaction should go in order to increase the number of moles. Now here you have 1 plus 4, 5 moles in the reactants, 2 plus 1, 3 moles in the products. So we need to increase the number of moles as the pressure decreases. So which direction should the reaction proceed? It should go in the reverse direction because the pressure reduced. So then the volume need to increase. Volume can be increased by increasing the number of moles. Number of moles will increase by going reverse direction. So as equilibrium re-established, the partial pressure of methane increases. Methane, if the reaction going for a reverse direction, methane is going to use up. So then the partial pressure of that need to decrease instead of increasing, right? And then the B, partial pressure, all the partial pressures will increase. It doesn't happen. the partial pressure of carbon disulfide increases. What do you think about that? So since the reaction is moving in the reverse direction, our products are going to be now hydrogen and carbon disulfide. So carbon dioxide will make more, so meaning the partial pressure of carbon disulfide increases. So that is correct, right? C is correct. And then the partial pressure of hydrogen and hydrogen sulfide decreases. Hydrogen here, hydrogen sulfide, this one. So they are not in the same side. So hydrogen should increase partial pressure, H2S decrease. Hydrogen sulfide decrease is correct but not hydrogen. E. The partial pressure of hydrogen decreases. Hydrogen partial pressure not decrease, it would increase because now the reaction is moving to the reverse direction, making more of hydrogen, so it should increase. Okay. Number 5. Magnesium hydroxide is used in several antacid formulations. Okay, so here we have magnesium hydroxide giving magnesium and hydroxide. Equilibrium constant given. 100 grams of magnesium hydroxide added to 1 liter of water and equilibrium established. What happens if another 10 grams of magnesium hydroxide are now added to the mixture? So you are adding 10 grams magnesium hydroxide. Now we have to look at the states of these reagents. Magnesium hydroxide is a solid. Magnesium aqueous, hydroxide aqueous. So what happened to the solution? Anything will change, any shift will happen if things in your QC will changes. What can we have in the QC? QC can have anything that is aqueous or that is gaseous. If there is a solid or liquid, we normally don't put those ones into our QC expression. So by adding a solid or adding a liquid, nothing will happen to the equilibrium. Okay, so you have to choose your answer wisely. Hydroxide ion concentration will increase. That's not correct. Nothing will happen. Solution will become supersaturated. No. Hydroxide ion concentration will decrease. No. The hydroxide ion concentration will be unchanged. So that is correct. Correct one is hydroxide ion concentration will be unchanged. None of these choices are correct. Also not correct. There is a correct answer. Number 6. Now number 6 also similar to number 5. Same way you can argue the statement and then find out the correct answer for this. And then number 7. Methanol can be synthesized by combining carbon monoxide and hydrogen. A reaction vessel contains the 3 gases at equilibrium with a total pressure of 1 atm. What will happen to the partial pressure of hydrogen if enough argon is added to raise the total pressure to 1.4 atm? Now you are adding argon here, right? Argon. What is argon? Which is an inert gas or a noble gas. And we talk about in the lecture what will happen if you add an inert gas. Okay, so by argon is not going to react with your reactants or the product. So by adding an inert gas, nothing will change. Okay, so you can choose your answer wisely knowing that. Number 8. At 450 degrees Celsius, a terbutyl alcohol decomposed to give you isobutane and water. What will happen if the volume of the container reduced by 50%? You reduce the volume. Volume decreases. If the volume decreases, what happened to the number of moles? The number of moles also need to decrease. Okay, so let's see which direction will give us the less number of moles. So here you have one number of mole. Here you have 1 plus 1, 2. So then which direction should we go to decrease the number of moles? The first two are not correct. Equilibrium constant will not change. The reverse reaction will proceed. The forward reaction will proceed. Which direction do you think? It should be the reverse, because the reverse reaction will give you from 2 to 1 moles. Okay. And then number 9. Container was charged with hydrogen, nitrogen and ammonia gases. What will happen if the volume of the container increased at constant temperature? So you are increasing the volume, and when you increase the volume, number of moles need to increase. Okay, so here you have 3 plus 1, 4 moles goes to 2. So if the volume increases, which direction should the reaction proceed? Making more number of moles, which is going to be the reverse reaction, this way, right? So then you can find your answer accordingly. More ammonia will be produced. That's not correct. There will be no effect. The equilibrium constant will decrease. Nothing happened to the equilibrium constant. Hydrogen and nitrogen will produce at the expense of ammonia. So there you have a correct answer, right? Ammonia will be used up, and since the reaction should go reverse direction, hydrogen and nitrogen will produce more. Okay, so I guess I will explain the other ones in the next video. Okay, bye bye.